In this lesson, we're going to look at evaluating each expression, and we're just going to jump into a practice page here that I have from one of my units. And so evaluate means to figure out how much this is worth if we use different x's. So evaluate again is kind of simplifying an algebraic expression, and we substitute. I'm sure that you love how long it takes me to write these. Substitute, okay, the value into the expression. So in this case, 64 divided by x. If x is 8, we have 64. Oof, that's really bad. Sorry. Got out of control there. 64 divided by 8. 64 divided by 8 is 8. 64 divided by 2. So 64 divided by 2. And sometimes I will have students write these out, but sometimes not. Something like this is relatively simple. 64 divided by 2 is 32. But when we get into some of these over here where we have exponents and multiplication and there might be some order of operations that we have to figure out, I would probably have them write out the steps. 64 divided by 4 is 16. And 64 divided by 16 is 4. All right, 3n minus 6. So when these are together, we talked about this being a coefficient and the variable. The fact that they are side by side means that they get multiplied. When a coefficient and a variable are right next to each other like that with no sign in between, that means we are multiplying. So this means 3 times 3 minus 6. 3 times 3 is 9, minus 6 is 3. One mistake you will often see with students who don't understand that this is multiplication is they will put the 3 in for n and they will say 33 minus 6. They will not understand or they will forget that this is supposed to be multiplying. So just putting the number in there and making it a new whole number is not correct. It is not 33 minus 6. All right, the next one is 3 times 6 minus 6. So 3 times 6 is 18. I'm not going to write out everything just for space. Minus 6 is 12. 3 times 9 is 27. 27 minus 6 is 21. And again, we're following the order of operations. We do always multiply before we subtract, and it's just convenient that in this expression, multiplication is before subtraction, so we don't have to think about which one comes first. 3 times 10 is 30. 30 minus 6 is 24. All right, when we get to something like this, we've got the exponent and the variable and the coefficient. So we're multiplying and we have exponents. If we think about our order of operations, we have parentheses come first, then exponents, then multiply, divide. So we've got exponents in the expression and we've got multiplication. So that means we have to do the exponent first. Now in this case, that gives us 3, and I'm going to put the multiplication sign, times 1 to the third. 1 to the third is 1, times 3 is 3. This gives us 3 times 2 to the third. 2 to the third, if you remember, is 2 times 2 times 2, which is 8. 8 times 3 is 24. This one is 3 times 3 to the third, which actually is like 3 to the fourth. 3 to the third is 27, and times 3 again is 81. And then lastly, we have 3 times 4 to the third. 4 to the third is 64. And 3 times 64 is 192. Okay. Now this one is a little bit less tricky because the exponent is separated by the addition sign. But still, we're doing the exponents first and then the adding. So we have 8 plus 2 squared. 2 squared is 4 plus 8 is 12. 8 plus 3 squared. 3 squared is 9. 9 plus 8 is 17. 8 plus 4 squared. 4 squared is 16, and 16 plus 8 is 24. And then we have 8 plus 5 squared. 5 squared is 25. 25 plus 8 is 33. Okay. So in each of these cases, we were evaluating and basically simplifying, which is another phrase we can use or another term we can use for finding the value of an expression. Evaluating or simplifying by substituting each number into in place of the variable. All right, we'll do a couple more. 25 minus x to the 4th power if x is 2. So 2 to the 4th power. 25 minus, and 2 to the 4th power is 16. And 25 minus 16 is 9. Okay, next example. Now you can't see this on the obviously on the back end, but I have made the same mistake in number 6 twice by substituting the wrong number in for x. So we're going to put the 9 in for x here, and since the variable is here twice, we'll put the 9 in for x here. All right, we've got a fraction. Now we've got 9/3 plus 4 times 9. 9/3 is equal to 3, and multiplication is happening before adding, so this is 36 plus 3 is 39. 2 to the 3rd power plus 5p minus 8 if p is equal to 3. So 2 to the 3rd power plus 5 times 3 minus 8. 2 to the 3rd power is 8 plus, these guys get multiplied because multiply comes before adding, 15 minus 8. Left to right, 23 minus 8 puts us back at 15. And then last but not least, we've got 16, which is 4 squared, plus, oh, I didn't rewrite that one, I apologize. 8 times 3 divided by 4. Multiply and divide left to right before you add. This is 24 divided by 4, and the 16 plus gets written again. Division comes before addition, so we have to do that part first. That is 6 plus 16 gives us 22. All right, so that is it for our evaluating or simplifying of those expressions. This little practice here at the bottom is just helping students understand the difference between something that can be variable and something that is constant. So if something is constant and you want to represent it in an expression, you're going to use a constant. If it is an amount that can vary, you will represent it with a variable. So we're just looking at things that are constant and variable. Number of days in March is constant. It's the same every year. The price of a cell phone is variable depending on perhaps how much extra things you have included in your bill each month. Your height. Now, for some of us, our height might be constant because we might be done growing and that's it. But for students, since they seem to be continuing to grow at this point in time, it's probably variable. The number of ounces in a pound plus height is variable for different people. So if you're not even thinking about it in regards to yourself, but yourself compared to other people, it's not all the same. It's variable. The number of ounces in a pound is always the same. That is a constant. The number of feet in a mile is the same. It's constant. The number of text messages sent per day varies from day to day and person to person. So that's a variable. The number of students in school varies from school to school and possibly from day to day and month to month. But the number of hours in a day are always the same, is always the same. So that is a constant. All right, so that wraps up our practice for evaluating expressions where we are substituting values in for the variables and looking at things that are constant and things that are variable. If you have any questions, let me know.